Welcome, my dear students. We are going to study the structure of sodium chloride and potassium chloride. The sodium, it has 11 electrons, chlorine has 17 electrons. Sodium donates 1 electron to other. It forms Na plus and the Cl minus accept 1 electron, it forms the Cl minus ion. Na donates electron to Cl, then Na forms Na plus and Cl forms a Cl minus. In case of KCl, the potassium has 19 electrons. The potassium, it donates to 1 electron to the Cl atom. Then Cl atom accepts the 1 electron and it forms the Cl minus. Potassium donate 1 electron to Cl atom and Cl accept 1 electron from the potassium. So the potassium and Cl atoms, K plus and Cl minus ions get formed. In case of NaCl, by donating and accepting the electrons, it forms Na plus and Cl minus ions. Since NaCl and KCl is isomorphous compounds, both of them should have a face center cubic structure, but because of X-ray scattering power differences, KCl apparently shows a simple cubic structure. The X-ray scattering power of an atom or ion depends on the number of electrons associated with it. In KCl, the K plus and Cl minus ions have equal number of the electrons, that is the 18 electrons. The potassium ion possesses 18 electron and Cl ion possesses the 18 electron. The sodium chloride, if you consider, then the sodium, it has the sodium ions, it has 10 electrons and Cl minus ion has 18 electrons. In case of KCl, there are equal number of electrons, hence they scatter the X-rays to the same extent. In the KCl crystal lattice, all atoms have the same scattering power, hence the unit cell of KCl apparently shows a simple cubic structure. In NaCl, sodium chloride, Na plus ion has 10 electrons, whereas Cl ion has 18 electrons. This results in a difference in their X-ray scattering powers. The 100 and 110 planes in both KCl and NaCl contain same number of K plus or Na plus and Cl minus ions. Hence, these planes will show similar type of X-ray reflections. But the 111 planes in both KCl and NaCl are made up of alternate layers of K plus or Na plus and Cl minus ions. The intensity of X-ray reflected by 111 plane containing all Cl minus ions is very high as compared to the intensity of X-rays reflected by 111 planes containing only Na plus ions. Thus, there is a difference in the intensity of X-ray reflected by Cl minus planes and by Na plus planes. Intensity of X-ray reflection for Cl minus ion is very high as compared to the Na plus ions. Thus, there is a difference in the intensity of X-ray reflected by Cl minus ions and by Na plus ion planes. In the case of KCl, the intensities of X-rays reflected by Cl minus planes and K plus planes are equal. Hence, these two reflected beams balance each other and no net reflection is obtained from 111 planes. As a result, the KCl unit cell behaves like a simple cubic structure. But the NaCl, there is a net reflection from 111 planes due to unequal intensities of the X-ray beam reflected by Na plus planes and Cl minus planes. Thus, the sodium chloride unit cell is a phase center cubic structure consisting of 8 simple cubes. Means the NaCl unit has phase center cubic structure. The conformation of structure of sodium chloride. In case of sodium chloride, the first order reflection from 100, 110 and 111 crystal planes using K line from a palladium anticathode are 5.9 degree, 8.4 degree and 5.2 degree respectively. The palladium cathode is used in the Coolidge tube, X-ray tube. From Bragg's equation, n lambda is equal to 2d sin theta. D is equal to n lambda upon 2 sin theta. Since n is equal to 1 and lambda is the same in each case, then d proportional to 1 upon sin theta. Therefore, d100 proportional to d110 proportional to d111 is equal to 1 upon sine 5.9 degree proportional to 1 upon sine 8.4 degree proportional to 1 upon sine 5.2 degree is equal to 1 upon 0.1028 proportional to 1 upon 0.1461 proportional to 1 upon 0.0906 is equal to 9.728 proportional to 6.845 proportional to 11.038. Then the is equal to 1 proportional to the 0.7036 proportional to 1.135. Thus, ratio is almost identical to the ratio for a phase center cube, that is 1 proportional to the 0.707 proportional to the 1.150. Means ratio by calculation and by the ratio by phase center cubic structure is the same. This confirms the NaCl belongs to phase center cube type of a crystal. Similarly, for KCl, confirmation of structure KCl. For KCl, the theta values for first order X-ray spectrum for 100, 110 and 111 crystal planes are 5.220 degree, 7.3 degree and 9.05 degree respectively. Therefore, D100 proportional to D110 proportional to D111 is equal to 1 upon sine 5.22 degree proportional to 1 upon sine 7.3 degree proportional to 1 upon sine 9.05 degree. Then is equal to 1 upon 0.0910 is equal to 1 upon 0.1271 proportional to 1 upon 0.1573. Then ratio is 10.989 proportional to 7.868 proportional to 7.357. Then is equal to 1 proportional to 0.716 proportional to 0.578. Thus, ratio is almost identical to that for a simple cubic structure, 1 as proportional to 0.707 proportional to 0.577 proves that the KCl is a cubic structure, simple cubic in a structure. Means the ratio 1 as to 0.716 proportional to 0.578 is same as 1.0707 proportional to 0.577 is identical. So the structure of KCl is a simple cubic structure. Thank you.